So what do we have in between? In between there are nothing but repetition of the same triangular spectrum after every 2 pi by d. So one will be at 0, one is at 2 pi by d, one is at 4 pi by d, 6 pi by d, and finally 2 pi by d into d minus 1. So this is the repetition that we obtain. And please do not forget that after this there will be this original spectrum present as it is. So let me draw that also quickly. But please note that this spectrum is not due to the repetition in y of omega. This spectrum is because it's originally present in x of omega. So now this spectrum x of omega, which comes as it is to y of omega, will also keep on repeating. We will be only interested in the spectrum which are from minus pi to pi. Pi is somewhere here, and we can see in this range the original x of omega spectrum are repeating. So now we have to draw one last spectrum which will be nothing but y of omega again, but this time we will draw it with respect to omega y. So for that we have to recall the relation between omega y and omega x. The relationship between omega y and omega x is something that we have already used. We can quickly derive it somewhere here. If you remember, the original sampling frequency was fx, and we had expressed a new sampling frequency of fy. Fy was represented as fx by d due to the downscaling. Now we know that any digital frequency omega can be written as 2 pi into analog frequency upon the sampling frequency fx. So that's my omega x, and omega y similarly will be 2 pi f upon fy. So now if you just compare the two, you can see omega y will be nothing but 2 pi f. This 2 pi f will be omega x into fx. So if I bring it here, I'll get omega x, and fx by fy will be nothing but omega x into d. So this is a relationship between omega y and omega x. So let us use this relationship. We have got the waveform with respect to omega x, and now we want to convert it to omega y. So how will that be possible? All we have to do is multiply omega x axis by d. So when I do that, I'll get exactly the same spectrum as it is. The only difference will be the entire omega x will be multiplied by d. So this is how new y of omega with respect to omega y will look like. We have multiplied omega x by d. So you can see the first spectrum that was between minus pi by d to plus pi by d is now present between minus pi to plus pi. The second spectrum that was from pi by d to 3 pi by d is now present from pi to 3 pi. And so on. The last spectrum, which was present around 2 pi by d into d minus 1, will be only present around 2 pi into d minus 1. And the new spectrum, which was around 2 pi, will now be present around 2 pi into d, because we have multiplied the entire omega x axis with respect to omega. So this point pi will now be pi into d. For any frequency spectrum, we should only be interested in the spectrum which is in the range minus pi to plus pi, because that's the range of omega. Outside anything we are not interested into. It will be repetition of the spectrum between minus pi to pi, and exactly the same thing is happening here also. So finally, when I draw a spectrum of y of omega, I will only keep the spectrum which is from minus pi to pi.